Hello everyone, welcome to Pepcoding. So in this video we are going to discuss the solution on the question longest zigzag path in a binary tree. So what this question is saying is, let's consider we are having a binary tree. We know the property of binary tree that a node can have at the most two childs or zero childs. Okay, or zero childs. Like we can have minimum of zero childs, it can have one child, or at most it can have two child. We know this property, right? Now let's say this is a binary tree given to us, something like this. Okay, and at the right side there is something like this. So what this question is asking is, this question is demanding that we have to return, if this is the main root node, we have to return the maximum zigzag path, uh maximum zigzag path that is available in this binary tree. So what is the zigzag path? Let me tell you. If I take a if I travel to left child, then I have to travel to right child, then I have to travel to left child, right and left. What I am saying is, the zigzag path is nothing but, if I start from left call, that is if I go to left child, if I go to left child, then I have to go to right child. Okay, to have the zigzag path, I have to go to right child, and then similarly I have to go left, and and similarly I have to just go on. If I go to right child, that is if I go to right child, then I have to compulsory go to the left child to get the zigzag path, and then again right, and similarly this will keep going on. So with this, I hope the question is clear to you all. We have to just return the maximum zigzag path. So the maximum zigzag path, or the longest zigzag path, can be in the left subtree or can be in the right subtree, right? These are two possibilities. If this is the question, then what will be my faith and expectation? My faith and expectation will be that if I'll just call this slash, that is the left call or left. If I travel to left child, then I'm going to call it as forward slash. And if I'm going to travel to right child, then I'm going to call it as a backward slash. Okay, so what is my faith going to be? My faith is going to be that if uh, if I am at this position, then I am going to ask my left child that give me the longest zigzag path from your family, and similarly I am going to ask to my right child that give me your longest zigzag path from your family, and I am going to compare both of you, and wherever I find the maximum zigzag path, that is the longest zigzag path, I am going to get included with that child. That means if I am currently standing here, and if I found if I get the longest zigzag path from left subtree, that is by making forward slash, then sorry, not forward slash, but if I get the maximum zigzag path from the left subtree, then obviously to go to the left subtree or go to the left child, I had to make a forward slash, right? I had to make a forward slash. So I am saying that if I am the parent and I am getting the longest zigzag path from right slash, which means if the answer that I am getting is, I'll write here, if the maximum zigzag path in the both the trees, first if it is coming with this backward slash, if the maximum zigzag path that we are getting is coming with backward slash, then obviously to go to the backward slash, I had to first take a forward slash. So I am saying that I had to make a forward slash, right? Therefore, this backward slash answer is lying where? Is lying at the left subtree of the root node, right? So which this means that if I am getting my answer from the backward slash, that is maximum zigzag path, if I am getting my maximum zigzag path or longest zigzag path using a backward slash, then the final answer is going to lie at the left subtree, because to make the to get the to go to the backward slash, first I have to make a forward slash, right? Similarly, if I am getting my answer from forward slash, okay, if I am getting my answer from forward slash, Then to go to the forward slash, I had to take a, I had to make a backward slash, right? If this was my root node, then first I have to make a backward slash, then I'll be getting my answer from forward slash. So with this, I hope this is clear that if I'm getting my answer from backward slash, then the answer is lying in the left subtree, because to go to the backward slash, this is, I have to make, if I'm getting this answer, sorry, if I'm getting this answer as in backward slash, this is my backward slash. So to go to the backward slash, I had to first make a forward slash, then I was able to get the answer in the backward slash. Similarly, if I'm getting my answer from the forward slash, then I have to make first backward slash call, then I'll be getting my answer. So this means that this means nothing but I have to find the answer keeping root node as the head. I have to find the maximum zigzag path. So first, what I'll check, I got an answer from backward slash, I got an answer from forward slash, that is I got an answer from left subtree, I got an answer from right subtree. Now what I'll check, as being the root node, I'll say that if I keep myself as a head, if I am the head of this whole zigzag path, then I'll check if I include myself in this zigzag path, then what will be the maximum path? Is it going to make any change? Like for example, I say, if I first I got a zigzag path like this, okay, now I will keep it, I'll be the root, I'll be the head of this family, head of this longest zigzag path, and I'll see if I'm first let's say, sorry, I'll explain myself again. If let's say I'm getting a longest zigzag path from right side, okay, from let's say from left side I'm getting of length 7, and from right side I'm getting longest zigzag path of length 8. What I'll do, as being the root node, what I'll do, I'll first keep myself as the family head of the family, and I'll check if I add myself to the left side, what will be the answer going to come. So if I become the head, the answer is going to come what? The answer is going to be 7, and this one, that is 7 plus 1, it is going to be 8. Okay, now I'll check if I be the head of the family, head of the longest zigzag path, and that longest zigzag path is coming from the right subtree, that is by making the backward slash. Then what is going to be the answer? It is going to be 8 and its own, that is 8 plus 1, it is going to be 9. So with this I am going to check the maximum answer, that keeping myself as the head, I'll check that what will the maximum of both those both the paths, and I am going to return that path. So that is going to be my answer. Now if we are clear with the, till this point, then there is a twist in this question. Okay, what is that twist? That twist is saying that twist is saying that, let's say, I'll copy this thing. This twist is saying that first I have checked, what I have kept myself root node as a head, that means I have included the root node, and I have checked that at which part I am getting the longest zigzag path. But now the twist is saying that there might be a possibility, that let's say we got to the right side, okay, we made a right call, then we found the longest zigzag path, or we found a zigzag path at the left part, that is we are going right left, okay. So this is a valid zigzag path like this. The twist is saying there might be a possible answer where the root node is not included. What this means? This means that there might be a possible answer where the longest zigzag path is present at this point, okay. The longest zigzag path is present at this point. There might be a possibility, or there might be a possibility that the longest zigzag path is present at this point, okay. So this is the twist. What this twist is telling us, that this twist is saying that first, the question till half was this, that if I include myself, that is the root, if the root node include itself, it has to find the longest zigzag path from right side or from left side, and it has to return the value, which means that if I am the head and I am having a longest zigzag path, that is going to be going to be my final answer. But the twist says that there might be a possibility in the left side, at some node where I was not able to reach by keeping myself as the head. If I keep this root node as the head, will I be able to go to this point? Is there any possibility that I'll be able to include this node as in the answer of the longest zigzag path? No, there is no possibility. Why? Because first I am going to left, then I have to go to right. I cannot go to left. Okay, therefore there if I keep root node as the head of this longest zigzag path, there is no possible way to go to this path. So I hope the question was clear. The second part of the question was clear, that the longest zigzag path can be present at any point. So I have to check three things. What are those things? Three things. First, I have to check that if I keep myself as the head of the longest zigzag path coming from the backslash or coming from the forward slash, that is coming from the left part, keeping myself as the head, I have to check that. Keeping myself as the head, I have to check the longest zigzag path from right side, and I have to check that if there is any longest zigzag path, not keeping myself as head, but keeping some another node as a head, is there any longest zigzag path present in the right side or longest zigzag path present in the left side? So this is what we are asking. Okay, so I hope that I was able to make myself clear. So the answer can possibly lie at this part or at this part or at the particular position where I am keeping root node or I am including root node in the longest zigzag path. After, just for case, if I include this and the longest zigzag path was present at this point, then our answer is going to be this, right? But what if this was not here? Then our answer, let's say it was something like this, then our answer was this. Okay, so I hope that I was able to make myself clear that what is this twist. So now we are going to see that how we are going to solve this question. What will be the approach? Now what we can say, that if we are having this diagram, okay, if we are having this diagram, first I'll ask the root node, I'll tell the root node, or I'll as keeping myself as the head, or say I am currently standing at the root node. Okay, I'm currently standing at the root node. What I'll say to my right child, I'm telling, or let's say not the right child. From here, if I have a faith that this left subtree, and this right subtree is bringing some answer. Okay, some answer, let's say 7, and this right subtree is bringing answer some, let's say 8. This is bringing the answer from where? This is the bringing the answer using what? Using forward slash. Okay, it is going to use forward slash, and this is bringing the answer using backward slash. Now I'll say that if I'm standing at the root node, the root node will say that first I'll include, or I'll keep myself as head, and I'll include, or I'll first pair up with my forward slash, that is first right side, and I'll see that what is the answer I am going to make, that is I'm going to add my 1. So this is going to be 9. So what this actually is telling me, that if I want to pair up with my right child, if I want to pair up with the answer that my right child has brought to me, then I have to make what? I have to make a backward slash, right? I have to make a backward slash. This is clear. That this means that if answer is coming in from this way, answer is coming, the final answer that is coming from the recursive function is coming from forward slash, then I have to just add my backward slash. That is, to reach that forward slash, I'm going to use my backward slash. Therefore, this is telling me that if I'm able to make if I'm going to make this, I have to check that if keeping myself as head, I have to check that if I'm going to make a longest zigzag path using my right child. Similarly, I'm going to check if I'm going to make the longest zigzag path using a forward slash. That is, if I'm going to make a longest zigzag path using my left child. There's the two things I have to check. I have to check, obviously I have to take the maximum of these two, right? And the third thing I have to check is if there is any another maximum path or longest zigzag path available or not. So what I'm going to ask my left child and right child, I am first telling my right child and left child, both the childs, that you bring the longest zigzag path, okay, longest zigzag path, but keeping me as the head. So what I'm saying is that if I'm the head of the family, if the root node is the head of the family, then obviously the right child has to bring the answer that is going to start, or let's say that is going to end with the forward slash. Okay, that is going to end with the forward slash. The right child has to consider this thing. If I am keeping root node as the head node, this is the head node, then I have to bring, the right child has to bring the answer ending with the forward slash. Similarly, the left child has to consider this thing, has to keep this thing in mind, that if I want to keep this node, this root node as the head node, then I have to bring the answer that is going to end with the backward slash. Okay, because obviously if the root node if the left child brings the answer that is ending with the backward slash, then only he can consider, or he can make this root node as the head of this family, head of this longest zigzag path. So these two things has to be very clear, that to be the head, I have to first get backward slash of the left, then I'll go to backward slash using forward slash, and similarly on this side. Now these things, these are the two things that this root node is going to ask to its left child and right child. There is another thing, that is this root node going to ask to its left child and right child. What it is going to ask? It is going to ask that don't consider me as the head. You have the free will. Just bring me the longest zigzag path. Let it be starting from any point, any node, but that has to be in your side. That is, if this is the root node, it will say that, hey left, bring the longest zigzag path. Don't consider me as the head of that zigzag path, but bring the longest zigzag path from your family. And similarly to right, hey right, bring the longest zigzag path from your family. Don't consider me as the head. And I'll do what? First I'll pair myself with you. That is, I'll pair myself with the longest zigzag path that you had bring, considering me as the head, and I'll compare between your longest zigzag path, your family's longest zigzag path, and me as the head of the zigzag path. I'll compare both those paths and I'll see which is the maximum. If I am the maximum, if considering me as the maximum, considering me as the head node, I'm getting the maximum longest zigzag path, then I'm going to return that. Otherwise I'll return the maximum zigzag path that your family is having, but not considering me as a head. So these are our this is going to be our faith and expectation, and this thing is going to solve a problem. So I hope this explanation was clear to you all. Let's try to code this, and after coding we'll get a more insight to this question. Now let's code this question. So what we are going to do, what we are given here, we are given here a pair function that is going to return some intent value, that is going to return a pair value of integer, pair of integer values. So here what we are going to do, let's start with this. We know that our base case is going to what? Our base case is going to be when root is going to be equal to null pointer, that is the root is going to be null. What we have to do, we have to return something. Okay, let's talk about this later, that what we have to return. Okay, I'll just mark it as have to return something. Okay, this is an abstraction for now. Let's keep it as it is. Now what we have to do, first we have to make a left call, and then we have to make a right call. That is, first we are going to make a call to our left child and right child. Okay, so for we do here int. Okay, here I say left is equals to dfs of root dot left, that is root of left. Similarly, I'm going to make a call to right child. Okay, similarly it is also going to get some uh, value that is going to be of integer type, but a pair of two integers. So right, okay, now these two things are done. Now what we have to do, we have to update our answer. That is, we have to update our answer with what? Maximum of, first what we have to check, I'm keeping myself as a root node, and I'm going to get some values. That is, I'm going to keep myself, I'll show it. What we have to do, we have to first keep myself as the root node, that is the main node. Instead of root, I'll say head node, and I have to first check for the answer coming from the left side. For answer coming from the left side, what we are actually making here, we are making a forward call. So my answer that is going to be attached at this forward call is going to be a backward call, right? So what I'm going to store in the pair, if this is my pair of int type and int type, that is at the first position and at the second position, what I'm going to store, at the first position I'm going to store forward slash answer coming from forward slash, and at the second position I'm going to store the answer coming from the backward slash. Okay, so now what I can see here, if I consider myself as the root node, I'll be making a left call, that is, I'm going to be at the left. And now where I'm going to find my answer, I'm going to find my answer at backward slash. And at in the pair, where is my backward slash stored? My backward is stored at the second position. So can I say that at the backward of the left, or instead of backward, I can say that if I make a left call, then my next answer, or the next this list is going to be stored at the second position. And similarly, if I make a right call, then the list is going to be stored at where? If I am the root node, I make a right call, that is, I make a forward call, my answer, sorry, not the forward, the backward slash, then my answer is going to be stored at this forward, that is going to be left, right? And my forward is stored at where? At the first position. So for the right, I can say that my remaining answer, if I make the right, if I decide to go with the right child, my remaining answer is going to be stored at the first index, that is first index. So this is all, this is the thing we are going to do here. So first I have to find the max of left dot second, comma, right dot first, sorry, first. And I have to add my one there. Why I have to add my one? Because to go to this backward slash, or I had to make a jump of one, or I have to attach my way also. To go here, I have to attach my way here. So I'm doing, I am just finding the maximum of these two without joining me. And after I get the maximum of these two, I'll join myself. This is what I'm telling. But this is not a final answer, because every time I have to update my answer, that is, I have to check myself also. So I'll be using another max answer of max. Now with this, what we are going to return, we are going to return a new pair, or let's say we are going to return left dot second plus one, comma, right dot what we can say, first plus one. And this is going to be in a pair format. Now to think of the base case, when we hit these, let's say when I hit a value or hit a node, when I reach to a node where there is nothing joined to it, that is the leaf node, then what should I return? As we are discussing edge based things, here we are discussing the longest zigzag path in the edge based kind of thing. Like we have already discussed in the level 1 that what is edge based height and what is node based height. Similarly, when we are talking about the longest zigzag path, we are talking about the edge based longest zigzag path. So whenever we reach to the null pointer, or whenever we reach to the null node, we have to return -1. So this is what we are going to return. We are going to return -1 and -1. Now with this, our code is done. Let's try to run this code, and it is giving us the 0. Is it the correct answer? Let's see. No, the sample output should be 4. There is some mistake that we have made. Let's try to figure out that mistake. Okay, let's see what is the mistake that we are making. Return -1. Okay, right. Make a call to the left child, store the answer in the pair format, right? Dot max, maximum of these two. Answer is getting updated. Okay, returning, making a call to this root DFS. Oh yes, we are returning 0 here. Instead of this, we have to return answer. That was our mistake. Let's try to run this code now, and it is giving us the correct output. Let's try to submit this code, and it is passing for all the test cases. So I hope this video is clear to you all. So thank you for this video. Let's meet in the next video.